Have you ever wondered what space sounds like? We always imagine the universe as this endless, silent darkness, right? Because technically, there's no air in space, and without air, sound can't travel. So for years, scientists believed the cosmos was completely silent. No whispers, no echoes, just pure nothingness. But here's the twist. That's not the full story. In the vast emptiness of the universe, there are sounds, just not the kind we can hear with our ears. They're hidden inside waves, vibrations, and frequencies. And when scientists started to translate those signals into something audible, what they discovered was beyond anything we'd ever imagined. Think about it, the universe, which we thought was silent, actually has a voice. A deep, rumbling, cosmic voice that's been echoing for billions of years. From the birth of galaxies to the collision of black holes, the universe has been singing this entire time. We just didn't have the right instruments to listen, until now. For decades, scientists searched for a way to listen to the universe. But how do you capture something that doesn't travel through air? That's where the story of gravitational waves begins. In 1916, Albert Einstein predicted them invisible ripples in space-time, caused by some of the most violent events in the cosmos. Imagine tossing a rock into a calm lake. The ripples move outward, carrying the memory of that impact. Now, replace the lake with the fabric of the universe itself. That's what gravitational waves are, ripples created when massive objects like black holes or neutron stars crash together. For almost a century, Einstein's theory remained unproven. Scientists believed in it, but no one had actually heard these waves until a breakthrough finally arrived in 2015. That year, the Laser Interferometer Gravitational Wave Observatory, better known as LIGO, recorded something extraordinary. Two black holes, over 1 billion light-years away, had collided. The shock wave from that ancient cosmic event reached Earth, and LIGO detected the faintest vibration ever measured. It wasn't a loud explosion or a dramatic roar. It was a soft, rising chirp, a sound that lasted less than a second. But that tiny signal confirmed one of Einstein's greatest predictions and forever changed the way we hear the universe. After that first detection, everything changed. The universe wasn't silent anymore. We could finally hear it. But let's pause for a second. How does something like LIGO even listen to space? There's no microphone floating out there, right? LIGO works in a completely different way. It uses two long tunnels, each 4 kilometers in length, set up in an L shape. Inside them, powerful lasers bounce back and forth between mirrors. If a gravitational wave passes through Earth, it stretches and squeezes space itself, and those laser beams shift ever so slightly. We're talking about a change smaller than a single proton. Let that sink in for a moment. LIGO can detect distortions 1,000 times smaller than an atom. It's like trying to notice the distance between Earth and the Sun changing by less than the width of a human hair. Unbelievable, right? That's why LIGO's achievement in 2015 was such a big deal. It proved that we now have the technology to sense the faintest echoes of the most powerful events in the cosmos. And here's the mind-blowing part. Every chirp LIGO detects isn't just sound. It's a story from deep space, a record of something that happened billions of years ago. So when you hear that soft, rising tone, you're not just listening to noise. You're hearing the death dance of two black holes echoing across time and space. Now here's something even more incredible. That chirp, that tiny rising sound, wasn't just random cosmic noise. It was the sound of two massive black holes colliding. Each one was about 30 times heavier than our sun, and they crashed together over 1 billion years ago. When they merged, they released more energy in just a fraction of a second than all the stars in the visible universe combined. Just imagine that. Two invisible giants spiraling toward each other faster and faster until, boom, they became one. sending ripples through the very fabric of space-time. And those ripples, they traveled across the universe for over 1 billion years until they finally reached Earth and gently brushed past the detectors at LIGO. That's what we heard. Not sound waves, but space itself being stretched and squeezed. And here's the really poetic part: when scientists converted those ripples into sound, what came out was that little chirp, a cosmic whisper that had been traveling since long before humans even existed. Think about that for a second. That faint sound had been echoing through space since before life began on Earth. But let's pause for a second. How did scientists even know what they were hearing? Well, it's not like there was a giant microphone floating in space. Instead, LIGO used 2 enormous laser detectors, each shaped like an L, with arms stretching out 4 kilometers in opposite directions. Here's how it works. A laser beam is split in 2 and sent down each arm. The beams bounce off mirrors and come back to meet again. If nothing disturbs space, they line up perfectly. But if a gravitational wave passes by, it literally stretches one arm of the detector and squeezes the other, changing the timing of the beams by a distance smaller than 1,000th the width of a proton. Yeah, you heard that right, a proton. We're talking about movements so tiny that even the most advanced technology barely catches them. So, when LIGO's system detected that faint distortion, scientists realized it wasn't noise. It was something big, something coming from deep space, the echo of 2 black holes merging billions of years ago. And that was the exact moment humanity heard the universe for the first time. The moment that signal came in, scientists froze. It was short, just a tiny chirp that lasted less than a second. But that sound carried the story of 2 enormous black holes spiraling into each other at incredible speeds. Think about it, each black hole had dozens of times the mass of our sun, and when they finally collided, they released more energy in that instant than every star in the universe combined. Crazy, right? And yet, that massive event happened more than 1 billion light years away. By the time the signal reached Earth, it was so faint that it literally moved LIGO's mirrors by less than the width of an atom. Still, that was enough. Enough to confirm something Einstein had predicted over 100 years earlier, that space itself can ripple. Imagine dropping a stone into a pond. The ripples spread out, getting weaker as they move away. That's exactly what happened here, except the pond was the fabric of the universe. So yeah, what LIGO picked up wasn't just noise. It was the sound of space itself moving, the first recorded whisper of the cosmos. When the news broke, the world of science went wild. For decades, gravitational waves had been just an idea, something only written in Einstein's equations. But now, they were real. We could finally hear the universe. And get this, LIGO didn't just capture one event. After that first detection in 2015, scientists recorded dozens more, each one coming from different black hole collisions or even from merging neutron stars. Every chirp told a different story. Some happened billions of years ago, long before Earth even existed. Others came from cosmic regions we'd never seen before. It's like suddenly gaining a new sense, as if humanity just learned how to listen. We used to look at the universe with our eyes through telescopes. Now, we can also hear it, and that changes everything. Because sound waves, or in this case, space-time waves, carry information light can't. They let us peek into places where light can't escape, like the hearts of black holes themselves. We're not just looking at space anymore. We're eavesdropping on the universe. So, what's next? Now that we can hear the universe, scientists are pushing even harder to tune in to new cosmic whispers. LIGO has already been upgraded, and it's working with other observatories around the world like Virgo in Italy and Kagra in Japan. Together, they're forming a kind of cosmic orchestra, each one listening from a different corner of the planet. And NASA's already planning space-based detectors too. like LISA, a mission that'll float in space and catch even deeper, lower frequency ripples. If everything goes right, we'll soon be hearing the collisions of supermassive black holes, millions of times larger than our sun. Imagine that the universe literally humming across billions of light years, and we're here, on a small blue planet, listening to its ancient song. It's a reminder that we're part of something much bigger, a living, moving, singing cosmos. So next time you look up at the night sky, remember it's not silent out there. It's full of music. We just had to learn how to listen.